Alright, so we're going to talk about how we get the bionic joints to stay there, basically. You can either cement them in, or you can have them uncemented. And we'll talk about that in a second. Now, uncemented we're referring to today is different to the way we talk about, say, when they implant teeth, where they screw it in. We're not quite talking about that, where it just directly screws into the bone. But we'll get into that. So, alright, your outcomes for today. First thing you're going to do is you're going to be able to describe how the different types of bionic joints are fixed into place. And you're going to outline the properties of the two methods, giving advantages and disadvantages of each. Now, we're not going to be super explicit about the disadvantages and advantages of each. You should, by now, be taking in the information yourself and having a think about it and synthesizing, so creating that understanding of the advantages and disadvantages. That's for you. Alright, let's go. So, cemented. Now, it's important to remember that bone is a living tissue. Now, it's not an inert thing. It is constantly doing stuff. And anyone's ever broken a bone and seen x-rays of when it's re-knitting back together, you can see that. So, there are two ways to attach artificial implants, particularly the big joints. There is cemented. So you cut off the diseased section of the bone, the medullary canal, and that is this section down the middle here. I'll turn the camera in case you need that. There we go, the highlight. That's this section here, inside. They fill it out with cement. It's a doughy bone cement, but it's a cement, so you need to really appreciate that. And the implant is sort of shoved in. Now it doesn't set straight away, so you can align it with the joint to make sure that it moves into place before the bone sets. Now, interestingly, it will sort of, if you watch a video of this, when they put the leg up there and they pop it in, often you'll just see it twisting, and that's it coming into line. Alright. The other side is uncemented, and this is much more interesting and complex, but has its own downsides, and we'll see that. So it's designed to wrap around the remaining bones. Again, they cut off what they need, remove it, and the cement-free implant is pushed again down that canal, same as it was here before. Okay. But it has a porous surface put on the outside, so it's got holes in it. Now, this is where it creates an interface between the bone and the implant. And what they do is, if given time, the bone will then grow in and fill up those holes and lock it in. Now, it takes longer. It takes a lot longer because you've got to wait for the body to go through it. And you can't put as much pressure on it straight away. And it's also, because you can't put as much pressure on it, sometimes the bone recedes, pulls away, and that can result in loosening. Now, both are vulnerable to loosening, so in other words, the implant becomes loose, but it's more likely a cement-free implant. Now, finally, before we move on, this is not a simple thing. Most people who need particularly hip replacements, are older. Is a very large and major surgery. Knee replacement is again major surgery, and because it is generally older people, it does have a significant toll on the body, and often can be fatal just through the shock of the operation on the body or complications. Just while we're here, you can see along this line where the bone is growing into it, which is on the other side here. The cement sort of fills up the rougher bone tissue. So, cement used in a cemented implant serves many purposes. Now, it allows the initial fixation. That's important. So fixation, fixing it there, sticking it there. It acts as a shock absorber. Okay, it's a viscoelastic polymer, and this viscous, so you can move through it, you can push through it. Elastic, stretch back. Okay, so they'll stick, and if you have a shock, it'll spread out. It helps spread the load more evenly over a large area. Okay, so there's less stress concentrated on that particular bone. Now, cement-free implant is coated with a porous layer. Now, again, as we said, it puts less pressure on the bone, which means it takes longer to set, but that's fine. And the implant grows into the bone. And that's it. That's your two differences. All right. Good luck. We're kind of finished with skeletons now. We're on the direct instruction for skeletons. That's pretty simple. You should have all that down. And yeah, stay rad and see you in class.